All right, so for this example, we're being told to find the following indefinite integral. And then once we find this indefinite integral, the next parts give us two different initial conditions, and using those initial conditions, we're asked to find c. So first, let's just do our indefinite integral. The integral here, 10 times x to the 5th over 5 plus 3 times x to the 3rd over 3 minus 11 times x. So this is all just using the power rule, where you increase the power on your variable and divide by that new power. And remember, always put plus c, because when we take the derivative, any constant's going to cancel out. So we never know what it is for sure and have to put plus c with your integrals. So if I reduce this here, that's going to give me 2x to the 5th. The 3's here cancel out, so I get x cubed. And then I just have minus 11x plus c. So that's finding the indefinite integral. That part's done. Now, the first initial condition we're given is what if, and remember, if we call this inside of here little f of x, then the result is usually called big F of x. So the first initial condition is what if big F of 0 were to equal 7? What is c then? Well, plug in 0 and solve for c. So f of 0 would be equal to 2 times 0 to the 5th, which is 0, plus 0 cubed, which is 0, minus 11 times 0, which is going to be 0 as well, plus c equals 7, because we're told that big F of 0 is 7. Notice all these terms drop out, and so I just wind up with c being equal to 7. Simple enough. The second initial condition was what if, instead, not at the same time, but instead of this, f of 1 was equal to 5. Same process, but we're plugging in 1 instead of 0. So here I would get 2 times, well, 1 to the 5th is still just 1, but I'll put it here, plus 1 cubed minus 11 times 1 plus c is equal to 5. Well, this is just 2 plus 1 minus 11. I'm going to subtract the 5 over, minus 5, and move the c over here, equals negative c. So since we're trying to solve for c, I'm just moving it over there. Let's combine like terms. Negative 11 minus 5 is negative 16, and 2 plus 1 is 3. 3 minus 16, that's going to give me negative 13 equals negative c. And so positive c is just 13. So if you're given an indefinite integral, you just do your integration, but always remember you have to put a plus c there because you don't know what this constant is. If you're given an initial condition for what big F of x is equal to for some value of x, then you can go through and solve for c. And notice how, depending on what your initial condition is, you're going to get different values for c. And these aren't consistent. These can't both be true at the same time. Notice that if we found that c was 7, and then we plugged in 1 using that, then we'd actually have 2 plus 1 for 3, minus 11 for negative 8, plus 7. So we'd get negative 1, not 5. Likewise, if we say that f of 1 is 5, we're going to get a different result when we go back up here. Namely, we'd get that c was still 5. So that's this example showing an indefinite integral and how the initial conditions can change what your constant is.